everyone. So in this question, we are asked to prove that one-sided inverse is actually a two-sided inverse. Okay, in a group. So first, let's understand what a one-sided inverse and a two-sided inverse is. Okay, so here in the definition of the group, what do we say? G is a set along with a binary operation, and this binary operation will satisfy associativity, and then there will be an identity element. Okay, and then the next condition what we are saying is given any A. This is from the definition of group G. What are we saying? Given any element A in G, okay, we can find the resistor B in G such that AB is equal to identity and BA is equal to identity. Okay, so if we are operating B from the left or from the right to A, we are getting identity. Okay, so B will act as a inverse of A from both left and right. Okay, so in this case, B is going to be a two-sided identity. Okay, B is going to be a two-sided identity. Now, suppose we are not given this information. Okay, so we are just given a group G. Okay, suppose that we are just given a group G. Okay, and we are taking an element A in G. Okay, now we are seeing that okay, while performing various operations and all, we just observed that one element B in G is when we are operating this A and B like A into B, that is we are operating B to the right of it. Okay, we are getting identity. Okay, this much we are observing. Okay, or this is what we are given. Now we have to prove that this same B, if we are operating from the left, still we will get identity. That is, we have to prove that BA is also equal to identity. Okay, so for that, to prove BA is actually equal to identity. So at present, we don't know what this BA is. We just know that from the since the operation is binary, we know that it will be some element of A, the group G. Okay, it will be some element of the group G. That much only we know. So let's just call it X. Okay, so let BA is actually equal to some X. Now we will show that this X is actually identity. All right. Okay, so here we have BA is equal to X. Now what will we do? The given condition is that AB is identity, right? So let's make use of that. So we will multiply on both sides by A. Okay, so we'll have A into BA is actually equal to A into X. Okay, now this is actually equal to AB into A is actually equal to AX by associativity. Okay, now what is this AB? This is actually identity times A. This is actually equal to AX. But what is identity times A? It is just A. All right. Now this A, we can also write this as A into E, right? Because we know that E is a identity element. Okay, and what will happen? We can write that AE. We'll have that EA is actually equal to A is actually equal to AE from the definition of the group. All right. Now we are given that group G is a group, right? So A inverse will definitely exist. Okay. So we can actually operate on both sides by A inverse. Okay. We don't know what that element A inverse is, but that definitely exists since group G, since given G is group, right? Or in other words, we can also say that the cancellation property will hold because G is a group, right? So we can cancel this A and then we will get that E is actually equal to X. Okay, but what is X? It is BA. So we have that BA is actually equal to uh, X. This is actually equal to identity. So we have proven what we wanted to. All right.